In 1891, newspapers reported the story of James Berkeley, a whaler who was swallowed whole by his prey. Supposedly, Berkeley spent as long as 36 hours in the belly of the beast before his crew caught the whale and rescued the crewmate, and this tale is far from unique. And various novels, myths, and religious texts depict figures swallowed at sea, with some even making a home for themselves in the creature's cavernous mouths. Unfortunately, if someone actually were swallowed by a whale, they would likely be crushed, but if they somehow survived, they might have a chance to escape during the captor's bathroom break. Whales frequently surface to take in air and let out a massive plumes of waste. And while swimming in the slowly might seem more disgusting than living in these creatures, whales' poop is much more desirable than it may seem. In fact, it may be one of the most important substances in the ocean and the world. To understand why, we need to look at some of the ocean's most ubiquitous organisms, phytoplankton. These creatures survive off sunlight, carbon dioxide, and nutrients like phosphates, nitrogen, and iron. And since the ocean's surface waters generally have an abundance of these resources, phytoplankton are everywhere. A single drop of seawater can contain certain of these creatures, and the phytoplankton blooms are large enough to be seen from space. These phytoplankton then become food for countless microscopic razors, including copepods and krill, which in turn feed a few spots of marine life. In this way, these surface dwellers are the base of the food chain, supporting countless marine life forms. But when phytoplankton die, their bodies can sink far below the surface, taking with them the carbon and the iron their living peers need to survive. And this is where whales comes in. Hunting at these depths, the whales consume huge amounts of these phytoplankton predators. For example, species like the blue whale can consume up to 16 tons of krill every day, leading them to regularly surface and release a slick of feces bred with iron. Through this cycle, whales act as a living pump to bring iron from deeper waters back to the surface. However, if we take whales out of the equation, much as centuries of commercial whaling did, this natural system starts to break down. Over enough time, this broken cycle could lead to surface waters completely devoid of life, and similarly major problems for us to land dwellers. Phytoplankton's massive photosynthetic blooms produce as much as half of the Earth's oxygen. In addition to taking in iron, phytoplankton helps sequester huge amount of carbon, an element we need to extract from the air to address climate change. According to one report, phytoplankton are estimated to capture 4 times the amount of carbon contained in the plant life of the Amazon. From these calculations, every 1% increase in the phytoplankton population is the carbon capture equivalent of 2 billion fully grown trees springing into existence. While there is still debate about exactly how much of this carbon stayed in the ocean long term, researchers are working to increase phytoplankton populations and bury as much carbon as possible. Some groups are doing this simply by springing iron in the ocean. However, this approach is much less impactful than supporting the ocean's natural phytoplankton farmers. Whale poop's complex matrix of nutrients is the result of millennia of co-evolution among these creatures, making it vastly superior to cheap man-made supplements. By now, whale populations are still recovering from industrial whalings, but if we can help these species rebound through whaling moratorium, safer fishing and shipping practices, and cleaning up pollution, it would wonder for restoring this nutrient cycle, even when these newly protected whales die natural deaths, they'll still be fighting climate change. Not only can whales' bodies sequester up to 33 tons of carbon at the bottom of the ocean, but their remains can also become an entire ecosystem, continue to support but the remains can also become an entire ecosystem, continue to support life both above and below the surface.